Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. The topic of this lecture is modulus argument form, that is r theta form in complex numbers. An important advice: be kind and be humble. You can find the link of the math website in the description where you can find the soft copy of this lecture. Modulus argument form, that is r theta form. The Cartesian form. This is the Cartesian form. This is also known as rectangular coordinate form or XY form. This is the modulus in Cartesian form and this is the argument in Cartesian form. This is the imaginary part of z and this is the real part of z. And this is the argument of z and this is the modulus of z. Polar forms, that is r theta forms. There are two polar forms. Number one, trigonometric polar form, and number two, exponential polar form. This is the trigonometric polar form and this is the exponential polar form. Let's understand how to transform the Cartesian form into trigonometric polar form. Using trigonometry, we can now write a complex number in modulus argument form, that is in this form and in exponential polar form. See, this is z, this is the imaginary part of z, y, and this is the real part of z, that is x. And this is modulus z, and this is equal to r, and this is the argument z. If we use sine theta and cos theta in this triangle, then we can get the values of y and x. So y is r sine theta and x is r cos theta. By substituting these values of x and y into Cartesian form, we can get the trigonometric polar form. Since x is r cos theta and y is r sine theta, therefore this is the trigonometric polar form. In this form, r means modulus z and theta means argument z. We can also write z for different powers. For z power 1, the form is r power 1 cos 1 theta plus I times sine 1 theta. Since this is 1, so r has same one, number 1, and the coefficients of theta will be same, 1 each. For power 2, z power 2, the form should be r square. This power will come here and this 2 will come here and here. Cos 2 theta I times sine 2 theta. And this is in general. Z power n is r power n cos n theta I sine n theta, where theta is in radians. Exponential polar form. As this result is equal to e power I theta, therefore by substituting this result into trigonometric polar form, we can get the exponential polar form. This is the exponential polar form, where r means modulus z and theta means argument z. The coordinate r theta are called the polar coordinates. We can also write exponential polar form for different powers of z. For z power 1, the form is r power 1 e power 1 I theta. For z power 2, the form is r square and e power 2 I theta. This 2 will come here and here. In general, z power n is r power n e power n I theta. Let's understand how to convert the Cartesian form into two polar forms, the trigonometric and exponential. To convert Cartesian form into these two forms, we need the modulus and argument of this complex number. The modulus of this complex number is under root 2, whereas its argument is pi by 4. Now we just need to substitute the value of r and theta into these two forms. So by substituting root 2 here and pi by 4 here and here, we have the required trigonometric polar form. And this is the required trigonometric exponential form. If this is z, then for z cube, we need to cube this number and we need to multiply these two angles by 3. So z cube is under root 2 cube cos 3 pi by 4 and I sin 3 pi by 4. If you will simplify this, then you will get the Cartesian form of z cube. We can also write z cube here. Z cube will become under root 2 cube and e power I times 3 pi by 4. An important application of trigonometric polar form. Show that under root 3 minus I is the root of this equation. There are two methods to prove this. The first method is the direct method. We can directly substitute this here, but this method is very lengthy. We have to use binomial theorem to expand this expansion. So to make the calculation simple and fast, we will use trigonometric polar form, this form. And we will use this form for power 6 because we have to prove this equation indirectly. So first we need to find modulus and argument of this complex number. The modulus and argument of this complex number is 2 and minus 5 pi by 6. Now we have to substitute 2 and minus 5 pi by 6 into this equation, this one, z power 6. So this will become 2 power 6 minus 5 pi by 6, 6 times minus 5 pi by 6. Hence shown that this is the root of this equation. This method is very simple and short.